I would like to start off with Starmus and about your lectures. What are you going to deliver and what do you expect from this festival?
So I'm speaking tomorrow. I'm going to talk about asteroids, and the title of my talk is Asteroids in Action, Fire on the Ground. So asteroids in action, normally there are millions and millions of asteroids and they float around. They orbit the sun, but they don't do much. So asteroids in action are when they run into a planet. And so occasionally an asteroid will collide with the Earth, it will enter the atmosphere, and it will explode. Or if it's big enough, it will penetrate the asteroid and make a crater. So my presentation is about the physics and the phenomena associated with those airbursts and impacts.
Talking about asteroids and the risks, are those risks manageable? And taking into account the opportunities of science and technology nowadays, are those risks manageable and how does science deal with that?
There is a risk associated with asteroids. It's a fairly small risk, but the consequences are enormous. So occasionally there will be a very large impact. The most famous one is the one that wiped out the dinosaurs 66 million years ago. But there are other very big crater forming impacts that if they happen now would be potentially catastrophic because they have an effect on the Earth's climate sometimes. And they also can do a lot of damage. Giant tsunamis, big ocean waves, earthquakes, debris. And so if that happened now with our modern civilization, it could destroy a city or even an entire nation. So even though they are very rare, we need to worry about those and, if possible, prevent them from happening. And we are studying ways to do that by deflecting the asteroid. If we find it early enough, we can change its speed very, very slightly so it arrives at the Earth at a different time that the Earth arrives at spot. It would arrive at Earth's orbit at a different time after the Earth has already passed so that they would miss. So you can avoid the collision. And another possible method is to just break it up into bits so that the bits are either small enough to not do damage or they entirely miss the Earth. So, and then the other way we can manage the risk for the very small ones like Chelyabinsk, which injured 1,500 people, is to find them in advance and warn people. If it's big enough, they could evacuate a city or they could take cover. So there are lots of different ways to manage risk.
And do you think if it's not possible to prevent, are people generally ready to deal with it? And you've talked about evacuation and stuff, but are states and people ready for that?
I think we need to work more on that. I mean, part of risk management, for example, from a hurricane, is to evacuate people. But we have to be able to predict the arrival of the hurricane. We have satellite systems that are very good at tracking hurricanes, and we have forecast tools that can show where they go. We don't have that technology in place for all asteroids now. For example, if one is coming from the direction of the sun, we wouldn't have a warning, and that's exactly what happened in Chelyabinsk in 2013. It came from the direction of the sun. We didn't see it coming, and it exploded with no warning. And if it had been much bigger than it was, it did a lot of damage the size that it was. It broke windows, people were injured by flying glass. If it had been much bigger, it could have been much, much worse. So we need the tools to detect them early to be able to predict their arrival so that people will be ready to either evacuate or take cover.
Talking about tools, it's the job of scientists to do that, but also I would love to talk about science communication. How important do you think it is for the scientists to talk publicly and openly about what they do in order for ordinary people to understand more science?
I think science communication is critical, and that's one of the things Starmus is doing. You really need to have all people engaged in understanding science, understanding risks, And so those of us that are involved in science that involves risk should be talking about it openly and publicly as much as possible so that people understand the risks. And that includes asteroids, climate change, earthquakes, volcanoes, tsunamis, hurricanes. There's a very long list of risks, and risks that we can understand with science and with the tools of technology, but we do have to communicate that.
Yes, and talking about also climate change, what we hear often is that people need to start to act in order to prevent some things and stop doing some other stuff. But as I see, as someone, not a scientist, not someone that has deep knowledge about that, shouldn't people firstly understand what the problems are and then start to act? How do you see the role of scientists here?
The role of scientists and the role of scientists in communicating science is important, but we also need people who are trained in communication. So scientists we don't have the training to communicate and explain things well. I think we're learning. I think we're realizing that it's more important, and it involves more than just going to conferences and talking to other scientists. We need to be better at telling stories, because I think non-scientists respond better to stories and anecdotes and analogies than, we're not going to say, go up on a blackboard and start writing equations. People are not going to pay attention to that. So we really need to make it personal for people. What is the risk to you and your family and your nation and your community?
Yes, and before I told you how big of event this is for Armenia, and also coming to science communication, is that in Armenia scientists are not used to talk about, so we still have this image of scientists working alone in a room and not really talking about what they do. So I think this is also a big opportunity for them to see and to maybe have some exchange of your experience and other scientists of communicating science and talking about that as well.
And I think the culture of science has changed. I think the scientists like Carl Sagan, for example, who was before his time in terms of science communication, he was very much engaged in science communication, but in some ways he was punished for that by his colleagues. They didn't value that activity as much as they would value, as like you said, if he went into a room alone and worked and wrote papers and went to conferences and ignored the public. We can't do that. We can't afford to do that. There are too many really important problems that we need to communicate to the public. And so I consider it part of my job. And also, my research is funded by taxpayers. So they're my boss in a way. I mean, the taxpayers are paying my salary, so I need to, it's really, I have an obligation to communicate what I do to them.
Thank you very much. It was a big pleasure talking to you.
Okay, thank you so much.
Thank you.
I appreciate it.